Hello, Parakoy. All the best sa review mo and wishing you all the best. God bless. Okay, power plant, question number 1. A boiler fuel contains 86.1% carbon, 12.5% hydrogen, 0.4% oxygen, and 1% sulfur. 40% excess air is supplied to the furnace and the fuel rate is 400 kilograms per hour. Calculate the quantity of heat energy transferred to the air per hour if it enters the air heater at 18 degrees Celsius and leaves at 130 degrees Celsius. Take Cp for air as 1.005 kJ per kgK and humidity ratio of 0.013 kgV per kgDA. And the answer would be 913,736 kJ per hour. Power plant question number 10. A waste heat recovery boiler produces 4.8 MPa dry saturated steam from 104 degrees centigrade feed water. The boiler receives energy from 5 kilograms of 954 degrees Celsius dry air. After passing through the waste heat boiler, the temperature of the air has been reduced to 343 degrees Celsius. How much steam in kilogram is produced per second? At 4.8 MPa dry saturated, H is equivalent to 2,796 kJ per kg. The answer is 1.3. Power plant question number 11. A steam boiler generating 25,560 kg per hour of steam at 4.137 MPa and 426.7 degrees Celsius, an enthalpy of 300,274.1 kJ per kg is continuously blown at the rate of 1,116 kilograms per hour with an enthalpy of 1,055 kJ per kg. Feed water enters the economizer at 148.9 degrees Celsius with an enthalpy of 629.87 kJ per kg. The furnace burns 2,700 kilograms per hour of coal with a higher heating value of 30,470.6 kJ per kg. Calculate the overall efficiency of the steam. The answer is 82.73%. Power plant question number 12. In a food processing plant, a brine solution is heated from 6 to 12 degrees Celsius in a double pipe heat exchanger by water entering at 50 degrees Celsius and leaving at 40 degrees Celsius at the rate of 0.166 kilograms. If the overall heat transfer coefficient is 850 W per 2m point degrees centigrade, what heat exchanger area is required for counterflow? Answer is 0.227 Power plant question number 13. A shell and tube heat exchanger must transfer 205 kilowatts to a solution with a specific heat of 3.26 kJ per kgK and change its temperature from 65 to 93 degrees Celsius. Steam is available at 250 kPa. Tsat is equivalent to 127.35 degrees Celsius. The unit convective coefficient is 340 W per 2m. K for the inside and 7,300 W per 2m, K for the outside. The thermal conductivity for the tubes is 111 W per mK, and the tubes have 4.0 cm OD and 3.0 cm ID and are 3 meters long. Determine the number of tubes required. Answer is 7. Power plant question number 14. A closed feed water heater with a transmittance of U is equals to 350 BTU per hour 2 FTF uses condensing steam at 20 psia. Tsat is 227.96 F for heating 85,000 pounds per hour of water from 60 Fahrenheit to 215 Fahrenheit. What is the transmitting area? Answer is 622 FT. For power plant question number 15, a deaerating heater operates at 26.7 psia. Tsat is 242.95 Fahrenheit and receives water at 181.6 Fahrenheit. Drains from higher pressure heaters enter in the amount of 168,000 pounds per hour at 303.7 Fahrenheit. The feed water flow from the heater is 673,000 pounds per hour. Calculate the steam flow for an enthalpy of 1,237.2 BTU per pound. The answer is 191,024 pounds per hour. Power plant question number 16. A cold storage compartment is 4.5 meter long by 4 meter wide by 2.5 meter high. The four walls, ceiling, and floor are covered to a thickness of 150 mm with insulating material which has a coefficient of thermal conductivity of 5.8 times 10 to W per mK. Calculate the quantity of heat leaking through the insulation per hour when the outside and inside phase temperatures of the materials is 15 degrees Celsius and 5 degrees Celsius respectively. Answer is 2,185 kJ. Power plant question number 17. The air inside electronic package housing has a temperature of 50 degrees Celsius. A chip in this housing has internal thermal power generation rate of 0.003 W. This chip is subjected to an airflow resulting in a convective coefficient H of 9 W per mK over its two main surfaces, which are 0.5 cm by 1 cm. Determine the chip surface temperature, neglecting radiation and heat transfer from edges. Answer is 53.33 degrees Celsius. Power plant question number 18. Water enters a 3 cm diameter tube with a velocity of 50 meters and a temperature of 20 degrees Celsius and is heated. Calculate the average unit convective coefficient. For water, kinematic viscosity is 1.006 times 10 6 2m. Prand number 7 and thermal conductivity is 0.597 W per mK. Answer is 86.6 kilowatts per m2k. Power plant question number 19. The total incident radiant energy upon a body which partially reflects, absorbs, and transmits radiant energy is 2,200 W per 2m. Of this amount, 450 W per 2m is reflected and 900 W per 2m is absorbed by the body. Find the transmissivity. Answer is 0.386.
Power plant question number 2. The constituents of a fuel are 85% carbon, 13% hydrogen, and 2% oxygen. When burning this fuel in a boiler furnace, the air supply is 50% in excess of the theoretical minimum required for complete combustion. The inlet temperature of the air being 31 degrees Celsius and exit gas temperature of 280 degrees Celsius. Calculate the heat energy carried away to waste in the flue gases expressed as a percentage of the heat energy supplied. taking the specific heat of the flue gases as 1.005 kJ per kgK. And the answer is 11.84%.
Power plant question number 20. What surface area must be provided by the filament of 100 W evacuated light globe where T is equivalent to 2482 degrees Celsius and emissivity, which is 0.38 for the filament? Assume the ambient temperature to be 25.6 degrees Celsius. Answer is 0.806 centimeter 2. Power plant question number 21. A flat circular plate is 500 millimeter diameter. Calculate the theoretical quantity of heat radiated per hour when its temperature is 215 degrees Celsius and the temperature of its surrounds is 45 degrees Celsius. Take the value of the radiation constant as 5.67 times 1011 kJ per m2 SK4. Answer is 1,863 kJ. Power plant question number 23. Question number 22 is cut. Okay. For question number 23, determine the monochromatic emissive power at 1.30 UM of a black body at a temperature of 1,500 degrees Fahrenheit. Answer is 1,233 BTU over hour FT2 UM. Power plant question number 24. Saturated steam at 500 K flows in a 20 cm ID, 21 cm OD pipe. The pipe is covered with 8 cm of insulation that has a thermal conductivity of 0.01 W per mK. The pipe's conductivity is 52 W mK. The ambient temperature is 300 K. The unit convective coefficient on the inside is 18,000 W m2K and on the outside is 12 W m2K. Determine the heat loss from 4 mm of pipe. Answer would be 821 W. Power plant question number 25. An insulated steam pipe passes through a room in which the air and walls are at 25 degrees centigrade. The outside diameter of the pipe is 70 mm and its surface temperature and emissivity are 200 degrees Celsius and 0.08 respectively. If the coefficient associated with free convection heat transfer from the surface to the air is 15 W per m2K, what is the rate of heat transfer loss from the surface per unit length of pipe? Answer is 998 W per meter. Power plant question number 26. The hot combustion gases of a furnace are separated from the ambient air and its surrounding, which are at 25 degrees centigrade by a brick wall 0.15 meter thick. The brick has a thermal conductivity of 1.2 W per mK and a surface emissivity of 0.8. Under steady-state conditions, an outer surface temperature of 100 degrees Celsius is measured. Free convection heat transfer to the air adjoining this surface is characterized by a convection coefficient of 20 W per m2K. What is the brick inner surface temperature in Celsius? Answer is 352.5. Power plant question number 27. A cubical tank of 2 meter sides is constructed of metal plate 12 mm thick, contains water at 75 degrees Celsius. The surrounding air temperature is 16 degrees Celsius. Calculate the heat loss through each side of tank per minute. Take the coefficient of thermal conductivity of the metal as 48 W per mK. The coefficient of the heat transfer of the water 2.5 kilowatts per m2k, and the coefficient of heat transfer of the air 16 W per m2k. Answer is 224.3 kJ. Power plant question number 28. A steel pipe is K is equivalent to 45.0 W per mk, having a 5.0 cm OD, is covered with a 4.2 cm thick layer of magnesia. K is equivalent to 0.07 W per mk, which is in turn covered with a 3.4 cm layer of fiberglass insulation. K is equivalent to 0.048 W per mk. The pipe wall outside temperature is 370 K and the outside surface temperature of the fiberglass is 305 K. What is the interfacial temperature between the magnesia and the fiberglass? Answer is 329.6 K. Power plant question number 29. Determine the critical radius in centimeter for an asbestos cement covered pipe. KASB is equivalent to 0.208 W per mk. The external heat transfer coefficient is 1.5 BTU per hour F22 degrees Fahrenheit. Answer is equivalent to 2.44 centimeter. Power plant question number 3. In an experiment to determine the calorific value of an oil fuel by means of a bomb calorimeter, the mass of the sample of fuel was 0.75 gram. Mass of water surrounding the bomb, 1.8 kilograms. Water equivalent of bomb and fittings, 470 grams. And the rise in temperature was 3.3 degrees Celsius. Calculate the calorific value of this oil in mJ per kilogram. Take a specific heat of water, which is 4.2 kJ per kgK. And the answer is 41.94 mJ per kilogram. Power plant question number 30. A 6-inch thick concrete wall having thermal conductivity K is equivalent to 0.50 BTU per hour, degrees Fahrenheit, is exposed to air at 70 degrees Fahrenheit on one side and air at 20 degrees Fahrenheit on the opposite side. The heat transfer coefficients are HI is equivalent to 2.0 BTU per hour, F22 degrees Fahrenheit on the 70 degrees Fahrenheit side, and H0 is equivalent to 10 BTU per hour, F22 degrees Fahrenheit on the 20 degrees Fahrenheit side. Determine the heat transfer rate. Answer is 31.25 BTU per hour FT2. Power plant question number 31. A hollow steel sphere contains a 100-watt electrical filament, and this data are known. R1 is equivalent to 9 inches. R0 is equivalent to 12 inches. The film coefficient for the inner and outer surfaces are H1 6, H0 2, BTU R FT2 degrees Fahrenheit. The environmental temperature is 80 degrees Fahrenheit. Assuming the steady state, compute the temperature inside air. Answer is 101.9 degrees Fahrenheit. Power plant question number 32. If a triangle of height D and base B is vertical and submerged in a liquid with its vertex at the liquid surface, compute the depth to its center of pressure. Answer is 3, 4, D. Power plant question number 33. Gate AB is vertical and 5 feet wide by 3 feet high hinge at point A and restrained by a stop at point B. If stop B will break if the force on it reach 9,000 pounds, find the critical water depth. Answer would be 20.23 feet. Power plant question number 34. The weight of a certain crown in the air was found to be 15 N, and its weight in water is 12 N. Compute its specific gravity. Answer is 5. Question number 35. A balloon weighs 300 pounds and has a volume of 15,000 feet. It is filled with helium, which weighs 0.0112 pcf, the temperature and pressure of the air, which weighs 0.0807 pcf. What load will the balloon support? Answer would be 742.5.8 pounds. Power plant question number 36. If the center of gravity of a ship in the upright position is 10 meters above the center of gravity of the portion underwater, the displacement being 1,000 metric tons, and the ship is tipped 30, causing the center of buoyancy to shift sidewise 8 meters. What is the value of the moment in kilogram per meter? Answer is 3 m kilogram per meter. Power plant question number 37. An open tank, 1.82 meters square, weighs 3,425 N and contains 0.91 meter of water. It is acted upon by an unbalanced force of 10,400 N parallel to the pair of sides. What must be the height in meter of the sides of the tank so that no water will be spilled? Answer is 1.2. Power plant question number 38. An open vessel, 30 cm in diameter and 90 cm high, is filled with water to a depth of 45 cm. Find the magnitude of the velocity in rad per s such that the vortex is just at the bottom. Answer is 28.01. Power plant question number 39. A liquid of a specific gravity, 1.75, flows in a 6 cm horizontal pipe. The total energy at a certain point in the flow is 80 meters. The elevation of the pipe above a fixed datum is 2.6 meters. If the pressure at the specific point is 75 kPa, determine the velocity of flow and the power available at the point. Answer would be 37.85 meters and 146.979 W. Power plant question number 4. The mass analysis of a fuel is 84% carbon, 14% hydrogen, and 2% ash. It is burnt with 20% excess air relative to stoichiometric requirement. If 100 kg per hour of this fuel is burnt in a boiler, determine the volumetric flow rate of the gas. If its temperature and pressure are 250 degrees Celsius and 1 bar respectively. Note, air contains 23.1% oxygen by mass. R is equivalent to 8.3143 kJ per kg mole K. And atomic mass relationships are oxygen 16, carbon 12, hydrogen 1. The answer would be 2,759 cubic m per hour. Power plant question number 40. If the velocity of water is 8 meters and the pressure is 140 kPa on the discharge side of a pump, what is the head of the pump if the velocity is 4 meter and the pressure is 90 kPa before the pump? That would be 7.54 meter. Power plant question number 41. A 300 mm times 75 mm venture meter is inserted in a 300 meter diameter pipeline where water flows at 55 L. Neglecting loosses, compute the drop-in pressure head from the inlet to the throat. Answer is 7.9 meter. Power plant question number 42. The head loss in 50 meter of 12 centimeter diameter pipe is known to be 6 meter when liquid of specific gravity of 0.9 and viscosity of 0.4 PAS at the rate of 0.06 cubic meter. Find the shear stress at the wall of the pipe. Answer is 63.56 kPa. Power plant question number 43. Water flows at 0.2 cubic meters through a 300 millimeter diameter, 120 meter long pipe under a pressure difference of 200 millimeter per mercury. Compute the friction factor. Answer is 0.023.
Power plant question number 5. Steam at 30 bar, 375 degrees Celsius, is generated in a boiler at the rate of 30,000 kg per hour from feed water at 130 degrees Celsius. The fuel has a calorific value of 42 mJ per kilogram and the daily consumption is 53 ton. Calculate the equivalent engine power if the overall efficiency of the plant is 0.13. The answer is 3,349 kW. Power plant question number 6. The equivalent evaporation of a boiler from and at 100 degrees Celsius is 15 kg steam per kilogram fuel, and the calorific value of the fuel burned is 41.9 mJ per kilogram. Find the efficiency of the boiler. The answer is 80.8%. Power plant question number 7. An economizer receives hot gas CP 0.27 BTU per pounds -R and water in the ratio 1.56 pounds per lbW. The gas enters at 850 degrees Fahrenheit and leaves at 350 degrees Fahrenheit. The water enters at 120 degrees Fahrenheit. Find the exit temperature of the water and the LMTD for parallel law. The answer is 320.5 degrees Fahrenheit, 228 degrees Fahrenheit. Power plant question number 8. Steam at 285 psia. TSAT equals 413 degrees Fahrenheit. HG equals 1202.45 BTU per pounds. Enters a convective superheater in a saturated state and leaves at 600 degrees Fahrenheit. H is equals to 1316.4. The hot gas CP 0.241 BTU per pounds -F. Leave the superheater at 1150 F. There are 1.6 pounds lbs steam, and the total steam flow is 17,580 pounds per hour. If the transmittance is U equals 4 BTU per hour -FT2 Fahrenheit, find the temperature of gas entering the superheater and the heating surface area. The answer is 1,445 degrees Fahrenheit, 634 FT2.
Power plant question number 9. A 22.7 kilograms flow of air enters a preheater at 28 degrees Celsius and leaves at 150 degrees Celsius. 23.7 kilograms of exhaust gases. Cp is equivalent to 1.09 kJ per kgK enters at 315 degrees Celsius. The overall coefficient of heat transfer is 710 W per M2C. Determine the surface area for counterflow. The answer is 22.82 M2.
Question number 44. A square concrete conduit having a side of 0.788 meters carries water at a rate of 4 cubic meter per second using Hazen-Williams formula with C equals 120. Compute the head loss if the length of the conduit is 45 meters. The answer is 1.8 meters. Power plant question number 45. Find the equivalent length of 167 millimeter diameter pipe. F equals 0.024 for a reentrant pipe entrance with K equals 1. The answer is 6.958 meters. Power plant question number 46. Two pipes with the same friction factor and length are parallel. If the first pipe has twice the diameter of the second, what must be the ratio of their flow? Answer is 5.66. Power plant question number 47. A 16 centimeter diameter pipe of length 200 meter and surface elevation of 50 meters from the discharge of the pipe with F equals 0.03 and loss of head due to entrance coefficient K equals 0.5. What is the velocity of flow in meter per second? Answer is 4.95 meter per second. Power plant question number 48. Horizontal orifice under a constant head of 1.3 meter issues a jet which hits a 0.5 meter below the center line of the orifice and 5 meter horizontally from the vena contracta. What is the coefficient of velocity? Answer is 0.98. Power plant question number 49. What is the discharge capacity of a concrete pipe culvert 4 feet in diameter and 10 meter long if the difference in water level in the outlet is 1.52 meter? Assume coefficient of discharge of 0.74. The answer is 4.72 cubic meter per second. Power plant question number 50. A 35,000 kW plant has utilization factor of 71% and a load factor of 39.6%. What is the average load in the plant? Answer is 9,840.6 kW. Power plant question number 51. The annual peak load on a 15,000 kW power plant is 10,500 kW. Two substations are supplied by this plant. Annual energy dispatched through substation A is 27,500,000 kW per hour with a peak at 8,900 kW, while 16,500,000 are sent through B with a peak 6,650 kW. Neglect line losses. Find the diversity factor between substations and the capacity factor of the plant. Answer is 1.48 by 33.48%. Power plant question number 52. A furnace burns coal with the following ultimate analysis. C equals 80.17%, H equals 4.34%, O equals 2.69%, N equals 1.45%, S equals 0.84%, A equals 7.09%, W equals 3.42%. For 15% excess air and complete combustion, Determine the actual air needed per kilogram if water is to be included and air is at 28 degrees Celsius and 0% RH. W equals 0.0143 kgV per kgDA. Answer is 12.43. Power plant question number 53. A natural gas has the following percentage volumetric composition. CH4 equals 59.8%. C2H6 equals 37.6%. N2 equals 2.2%. Carbon dioxide equals 0.4%. Calculate for complete the weight of air supplied including moisture if air is in excess of 25% and at 28 degrees Celsius and 50% RH, 0.012 kgB per kgDA. Answer is 20.27. Power plant question number 54. 200 metric tons per hour of coal are burned in 125% stoichiometric air. The as-fired ultimate analysis is 75% carbon, 4% hydrogen, 0.5% S, 6% oxygen, 1.5% nitrogen, 8% W, 5% ash. Find the mass of air needed to burn the fuel. The answer is 2,446.45 m ton per hour. Power plant question number 55. C18H18 fuel is burned with 25% excess. Calculate the weight of air needed including moisture if air is at 25 degrees Celsius and 60% RH. W equals 0.012. Answer is 19.04. Power plant question number 56. A vertical jet of water supports a load of 200 N at a constant vertical height of 2 meters from the tip of the nozzle. The diameter of the jet is 25 millimeters. Find the velocity of the jet at the nozzle tip. The answer is 21.13 millimeters per second. Power plant question number 57. A 50 millimeter horizontal jet of water with a discharge of 0.054 cubic meter per second strikes a vertical wall at 90 degrees to the wall. What is the force exerted on the wall? The answer is 1.49 kN. Power plant question number 58. A cylindrical tank, 10 meter in diameter and 5 meter in depth, contains water at 20 degrees Celsius, 9.789 kN per cubic meter, and is brimful. If the water is heated to 50 degrees Celsius, 9.689 kN cubic meter, how much water will spill over the edge of the tank? Answer is 4.05 cubic meter. Power plant question number 59. Two large plane surfaces are 1 in apart, and the space between them is filled with a liquid of absolute viscosity 0.02 thousand pounds per second feet. Assuming the velocity gradient to be a straight line, what force is required to pull a very thin plate of 4 feet square area at a constant speed of 1 feet per second if the plate is 1/3 in from one of the surfaces? The answer is 4.32 pounds. Power plant question number 60. A cylinder of 0.122 meter radius rotates concentrically inside a fixed cylinder of 0.128 meter radius. Both cylinders are 0.305 meter long. Determine the viscosity of the liquid that fills the space between the cylinders if a torque of 0.881 N-m is required to maintain an angular velocity of 60 revolutions per minute. The answer is 0.24 Pa-s. Power plant question number 61. A small drop of water at 80 degrees Fahrenheit is in contact with the air and has diameter 0.02 inches. If the pressure within the droplet is 0.082 psi, greater than the atmosphere, what is the value of the surface tension? The answer is 0.00492 pounds per feet. Power plant question number 62. Determine the ASHRAE number designation for dichlorotetrafluoroethane. CC1F2, CC1F2. The answer is 114. Power plant question number 63. Which of the following refrigerant does not belong to A1 safety group classification? Answer is R21. Power plant question number 64. A strainer has a coefficient CV rating of 60. It is to be used in a system to filter 50 GPM of water. What pressure loss expressed in feet of water can be expected? Answer is 1.6. Power plant question number 65. Compute the volume of expansion tank for a chilled water system that contains 2,000 gallons of water. The system is regulated to 10 psig at the tank with an operating temperature of 45 degrees Fahrenheit. It is estimated that the maximum water temperature during extended shutdown would be 100 degrees Fahrenheit. And the safety relief valve in the system is set to 35 psig. Assume standard barometric pressure and steel pipe. Take specific volume at 100 degrees Fahrenheit as 0.016113 feet cubic meter per pounds and at 45 degrees Fahrenheit as 0.01602 cubic feet per pounds. The answer is 5.2 cubic feet. Power plant question number 66. Estimate the exit temperature of 1000 CFM of air at 120 degrees Fahrenheit, flowing in a 16-inch round duct 24 feet in length. The duct has 1 inch of fibrous glass insulation, and the overall heat transfer coefficient based on the outside surface is 0.2 BTU per hour FT2F. The environment temperature is 12 degrees Fahrenheit. Take average density of air as 0.067 cubic feet per pound. The answer is 117 degrees Fahrenheit.